When we mention traveling to space, we often speak of gravity as an adversary. Gravity serves as the ultimate challenge and obstacle, preventing us from soaring among the stars and keeping us firmly rooted on Earth. Thus, it's not all that uncommon to think of gravity merely in terms of escape velocity, the speed that our spacecraft needs to reach in order to escape Earth's orbit, and nothing more. Hence, you might be surprised to find that engineers are trying their best at making artificial gravity for spaceships. There are multiple reasons as to why. Life without gravity. Let's start with convenience. Ever tried drinking a cup of water in zero gravity? The water will not move as you tilt the cup, making the act of drinking water really difficult. For this situation, astronauts use special cups designed to draw water due to capillary effect and surface tension, rather than gravity. These are called capillary cups and grind. They look pretty bizarre. Even the act of brushing your teeth or going to the bathroom needs to take into account the lack of gravity. Okay. We can handle drinking water from this cup. But let's talk about spills. Let's say you want to make a cup of coffee and spill some coffee grounds. In any normal circumstance, you would simply wipe the table you spilled it on with a wet cloth and be done. However, in zero gravity, the particles of the coffee will fly around everywhere. Good luck cleaning that up. Depending on what you spill, it could even conduct electricity, be flammable, and wreak havoc. So, now that you cleaned the mess you just made, you might feel inclined to do some exercise. In order for astronauts to do any proper exercise, they use special walking tracks with elastic straps to pull them down to the tracks. Every exercise is strap-based due to the lack of gravity. ISS astronauts exercise for 2 hours every day in order to avoid muscle atrophy caused by the lack of gravity, and even with this exercise, there will be other issues caused in the long term, as straps aren't exactly pulling down your organs, digestive tract, or blood. Prolonged exposure to microgravity causes loss in bone density, muscle atrophy, astronaut muscle waste, immune system, blood oxygenation, cardiovascular health, and even vision problems. A gravity substitute. So, now that we clarified why gravity would be welcome in a spaceship, let's focus on how to actually generate it. Gravity as a force itself is mysterious. It's the weakest out of the 4 fundamental forces: strong force, electromagnetic force, weak force, and gravity. It is speculated that gravity exists due to an elementary particle called a graviton, yet experts in the field remain uncertain. A lot of discussion around gravity is in the realm of theory. It remains a mystery even to this day. So, without any gravitons, how are we supposed to generate gravity? Well, we cannot generate gravity, but we can create the next best thing. It all comes down to the moment Sir Isaac Newton discovered gravity, when an apple fell on his head. Gravity on Earth can simply be chalked up to a force that pulls you down, hence, if it flies like a duck, looks like a duck, and quacks like a duck, it's gravity. Now, all we need is the force to do it. This poses a question: which force would be the most convenient gravity replacement? Magnetism? We'd need to have metal bones in order for that. Maybe for robots, but not for us. Or maybe just move with elastic straps everywhere. Strap even the coffee and the water itself. Scientists and engineers pondered on this for a long time and came up with a great nominee: centrifugal force. It's the same force rinsing your laundry in the washing machine. Let's say you are inside a cylinder and there is no gravity. Now all we need to do is set the cylinder to spin at a certain speed, and voila! You will fall to the walls of the cylinder, as if it were gravity pulling you there. This type of device is called an O'Neill cylinder, after the physicist who proposed a 2-cylinder device where each cylinder spins in the opposite direction, thus creating artificial gravity. Hopes and hurdles of artificial gravity in space. Jeff Bezos, owner of the space exploration company Blue Origin, has proposed the usage of O'Neill cylinders as the core of his orbital colony plans. Cylinders 32.2 kilometers, 20 miles, long and 6.4 kilometers, 4 miles, in diameter would generate spaceship-wide gravity for possibly millions of people living in such a space colony. However, such a design is too big for, let's say, a smaller ship meant for exploration. That's where researchers at the University of Boulder, Colorado, come in with their smaller proposal, able to generate artificial gravity in a single room, allowing for passengers to experience Earth-like gravity. What are your opinions on artificial gravity? Please let us know in the comments below.